All right, 3-1. Linear inequalities and absolute value. So here we are. It says solve, then graph the results. And so we got to get x by itself. Subtract x from each side. We end up with 2x minus 4 is less than or equal to 10. Let's add 4 to each side. And we end up with 2x is less than or equal to 14. And lastly, divide by 2. Now, when we're dividing by a positive or multiplying by a positive, nothing happens to the inequality. It's just when you multiply or divide by a negative, that's when you'll need to switch those inequalities around. But if you're dividing by a positive or negative, that's just fine. And actually, we end up with x is less than or equal to 7, and let's graph that. That doesn't need to be a super graph. I wouldn't even worry about putting tick marks on it. Just give me 0, negative numbers, positive numbers. And we are looking for, so 7's off here on the right. It's positive, and it's a solid circle because it's or equal to. We're looking for where numbers are less than 7. So, for example, if I put in 0, is 0 less than or equal to 7? And yes, it is. So I'm going to shade towards 0. So towards 0. All right. Over here, we've got negative or 8 minus 2x divided by 5. And so we need to multiply both sides by 5. 5 divided by 5, that's just 1. And so we end up with 8 minus 2x is greater than 30. Here, we'll go ahead and work to keep all of our x's, keep our x's on the left. So I'm going to subtract 8 from each side, and that gives us negative 2x is greater than, what is that, 22. Divide each side by a negative 2, and when you divide by the negative, that is when you will switch your inequality, when you multiply or divide by a negative. And so we end up with x is less than negative 11. And so to graph that, we end up with, here's 0, negative 11. It's going to be an open circle because there's no or equal to. And now where are numbers less than negative 11? That's going to be towards the negative side. There's our solution, solution and graph for those two. Now, just as a reminder, why you would, just a little bit of room here, why you're going to multiply or divide, and I think you can kind of probably test that out on your own. Think if you had 5 is less than 10. Is that true? Well, yeah. But now if we divide each side by, let's say, negative 5, we end up with negative 1 and negative 2. But is negative 1 less than negative 2? In that case, no, it's not less. It's actually greater. I'd rather owe somebody $1 than owe them $2. And so in those cases, when you're multiplying or dividing by a negative, that's when you've got to switch the inequality. And if you ever forget, just pull some actual, just real numbers, just constants, and you can kind of show yourself why that might be. All right, hope that helped.